In this problem type, we want to find the slope and the y-intercept. And so we're given a graph that looks much like this. And I didn't draw all the little lines on. I didn't put the grid lines on. It would be much too complicated for our purposes. But I did draw the coordinates. I did draw the line, and I did label the coordinates at different points along this line. So there are two things we want to know. We want to know the y-intercept, which is the point where the line crosses the y-axis. Our x-axis is horizontal, our y-axis is vertical. So if we follow this line to where we meet up with the y-axis, we see that our y-intercept is 5. So we can just tell that looking at the graph. Now, can we calculate that if all we had were numbers on a page? Yes. But this problem type, we have the graph. So just read the y-intercept. So the y-intercept equals 5. Now, all we need are 2 points, any 2 points along this line, and we can calculate our slope. And we know that our slope formula, y2 minus y1 divided by x2 minus x1, that will give us the slope of that line. So I'm going to pick 2 points at random. I'm going to say 4, 3 and 8, 1. So what I want to do is I want to set up a t-chart. X, y, point 1, point 2. This way I know what's y1 and what's y2. Well, here's point 1, and our coordinates are 4, 3. We always write our ordered pairs x, y. So the 4 is the x and the 3 is the y. All right, take the second point. 8, 1. So now we know our y2 and our y1, our x2 and our x1. And all we have to do is plug that in to our pattern up here, to our formula. So y2 is the number 1. 1 minus 3. Then we have our x2, which is 8. We minus our x1. And so what we end up with is negative 2 over 4. Well, that's okay, but we're not quite done. And this is not in lowest terms. On the test, they're looking for the slope in lowest terms. So if we divide both the numerator and denominator by 2, what we end up with is negative 1 over 2. So our slope equals negative 1/2. So we have our y-intercept of 5. And we have our slope, which is negative 1/2. That's all there is to it.